Good morning all the students. Today we will start physics of 10th class. Especially in physics there are 5 chapters in our syllabus. First, electricity. Second, light. Human eye and the colorful world. Magnetic effect of current. And the last one, sources of energy. There are 5 chapters in our syllabus. Today we will start the first chapter of physics, electricity. As we know, electricity, that means it is a form of energy. In previous classes we already learned that energy neither be created nor be destroyed. We can change in one form to another form. So in this chapter there are many parts of electricity. First, electricity, that means it is in form of energy. Electric current. Electric current, which means the flow of charges. The flow of charges in 1 second is called electric current. The flow of charges. Flow of charges in 1 second, we can say the rate of flow of charge is electric current. If you define the electric current and indicate by a symbol of electric current I equals to Q upon T. I indicate for electric current, Q for charge and T time. Q, that means charge upon time. So electric current equals to charge upon time. That means we can write the formula of electric current I equals to Q upon T. Charge Q equals to N multiplied by E, where N number of electrons, multiplied by E for charge of electron. So we can calculate the charge by this formula I equals to Q upon T, where Q equals to NE, and the number of electrons which are present in 1 coulomb charge we can calculate by formula multiplied by the charge of electron. Okay, means the charge of electron in last class we know 1.6 into 10 to the power minus 19 coulomb. 1.6 into 10 to the power minus 19 coulomb. It is the charge of electron. So we put the value I equals to Q equals to NT and E divided by T. We can use also this formula. If you make the unit, SI unit of electric current, SI unit of current, international system, what is the unit of current in SI system, that means internal system. We can use again I equals to Q upon T. Q, charge upon time. What is the unit of charge? Coulomb upon second. Coulomb upon second, that means ampere. Now what is the SI unit of electric current? Ampere. So I, that means current, and what is the SI unit of current? Ampere. Similarly, the next topic we start, this is related to electric current. We can use in simple formula I equals to Q divided by T. Suppose I ask one question that how much current flow through a wire or current conductor in 5 coulomb charge for 5 seconds. That means Q equals to 5 coulomb time 5 second, then I equals to 5 upon 5, 1 ampere. 1 ampere. Now, current is used, measured by an instrument. That instrument is used to find the amount of current, measure the amount of current. We can use by an instrument, ammeter. So ammeter, it is an instrument which is used to measure electric current or amount in a given conductor. Now, it is always connected in series. In an electric circuit, we will discuss later after this class. Ammeter is always connected in series. Okay. Series, that means when two and more electrical appliances are connected end to end, we can say this is in series combination. An ideal ammeter has resistance becomes 0. We can say if an ideal ammeter is there, that means the resistance of ammeter should be 0. So this is the first topic of this chapter. I equals to Q upon T, charge upon time, Q n multiplied by E, and number of electrons multiplied by charge of electron. Charge of electron 1.6 into 10 to the power minus 19 Coulomb. Coulomb is a unit of charge. So what is the unit of electric current? Charge upon time, Coulomb upon second. This is called ampere. So this is the SI unit of electric current is ampere. We can use also small unit of current, milliampere. Milliampere, that means 10 to the power minus 3 ampere. Same as microampere, we can use, this is a sign of microampere. Microampere, 10 to the power minus 6 ampere. These two units also these are units of electric current which are used in especially our numericals. Milliampere 10 to the power minus 3 ampere, microampere 10 to the power minus 6 ampere. Now we will use in definition 1 ampere. 1 ampere, that means we define the term 1 ampere. 1 ampere, which means when 1 Coulomb charge, we can use I equals to Q upon T. So whenever 1 Coulomb charge flow for 1 second, then the amount of current in a conductor is 1 ampere. 1 ampere. I repeat once again, listen to me very carefully, that 1 ampere, which means when 1 Coulomb charge flow for 1 second in a conductor, then this is in 1 ampere electric current flow this wire or a conductor. So this is the we can say this is the 1 ampere. This is a 1 ampere, 1 upon. Now next topic, electrical potential difference. Electrical potential difference, that means before I start we take an example. If there are two objects, both are heated, such as this is an A and this is an B object. They have different their heat energy. A is more heater as compared to B. So this is very simple, that heat energy is transferred from A to B because it has more heat energy, more temperature as compared to B. Similarly, electric potential difference, that means this is a flow of charge. But consider this is an electric field. This is an electric field, and electric potential difference, that means the work done to carry, you can also write bring, work done to carry or bring per unit charge, 1 unit charge from infinite to any point in an electric field. This is called potential difference, electrical potential. Such as potential difference is denoted by V. V equals to W upon Q, where V potential difference, W work done, Q charge. So V equals to W upon Q, that means work upon charge, is called electric potential. I repeat again that what do you mean by potential? Electric potential, work done to carry per unit charge from one point to another point or from infinite to any point, it is called potential, electric potential. V equals to W upon Q, where W work done, Q charge. We can make the SI unit of potential work, that means joule charge, coulomb, joule upon coulomb, there is a new volt. So what is the SI unit of electric potential? Volt. Volt is SI unit of electrical potential. Now we use the another word, potential difference. If the work done to carry 1 unit charge from one point to another point, that means there are 2 points in an electric field. There are 2 points from electric field. What is the difference between potential, electric potential between 2 points? What is the difference between 2 points of electric potential? That means we can say this is potential difference. So potential difference V equals to W upon charge. We can make its unit work. What is the unit of work? Joule, SI unit. And charge, coulomb, joule upon coulomb. This is called volt. So this is the potential difference. Now there is an again such as ammeter. This is an instrument which is used to find the electric current. Similarly, we use an voltmeter. Voltmeter, this is an instrument which is used to measure, find the potential difference. Potential difference between 2 points voltmeter. It is always connected to parallel. It is connected to parallel